Right, welcome to the final section on chapter 13 on transforming curves. The final way of transforming a graph is to reflect, and reflections are really fairly straightforward. So first thing we're going to do is going to have a look at the y equals cos x graph. There it is. And if we multiply cos x by -1, we get this shape here, and you'll immediately notice that the original green graph has been reflected in the x-axis. So this point here is moved on this side of the x-axis. The distance here is 1, this is 1, this is a reflection. This value here at 40 degrees is 0.766. If you go down this way and you get to the purple curve, it will be 40 minus 0.766. So for the same angle, it's the same distance either side of the x-axis. Obviously, if you're already on the x-axis, that's where the mirror is and the point won't move. So clearly 180 will become 180 and 1 will be -1. So of course, we never have to multiply by -1, because if we multiply by -1, we may as well just call it minus cos x. So what happens when you multiply by a negative number? It has this idea of flipping the graph over in the x direction. Of course, we could make it bigger if we use the slider notation again that we did before, and we go to a equals -1. There's the graph that we've got. So the purple graph that we had a moment ago is now the black graph because they coincide. But if we go to -2, notice it not only flips the curve over, but it stretches it by a scale factor at the same time. So reflections and stretching that we did in part 2 are actually related. You can achieve that by using a number at the front of the function that is bigger than -1. So if it's -3 cos x, as in this case, it's a reflection in the x-axis and a stretch parallel to the y-axis by a factor of 3. So if you want to make a reflection in the x-axis, you basically put a minus in front of the function. So we'll just see that in a little bit more detail. Let's say you had the graph y equals x plus 30, and you know that that would be a shift, a translation -30 degrees along the x-axis. And then if you just simply put a minus in front, what you would notice is that the curve should simply flip over in the x direction, and indeed it does, and you can see that. So that's how you deal with a reflection in the y-axis. Now, cancel those. Let's try and think about a reflection in the x-axis. The y-axis. So there's y equals sine x. Let's do another curve. And on this occasion, what we need to do here is not multiply by something in front of the sine, but actually multiply by something inside the angle. And there you go. You can see that that minus that we've done there means that it's going to be a reflection in the y-axis. It also looks like a reflection in the x-axis, but it's actually a reflection in the y-axis, and we'll see that in a minute. Sine happens to have an unusual property where it can do that, and it looks like it's both, and in fact it can be, but not for all sine functions. But for sine itself, it does work. Now, obviously, we don't need the 1, so let's drop the 1. So let's just double check. The original curve is in green. There it is, 91. A reflection in the y-axis would leave us at -91. So if this is the mirror, you're the same distance away on both sides, 90 degrees on both sides. Obviously, if you're on the mirror, it won't move. So the two positions stay the same. This one is 180, so it will go to that one -180. This point here will go to this point here, and so on. So you can get any of these points just moving across in the direction of the y-axis. So if you see this -x at the front, that will have the effect of doing a reflection in the y-axis, okay? So there is a summary of the final section, which is on reflections. They can either be reflected in the y-axis or the x-axis. And I just wanted to finish by building up a set of transformations that we've done before. So if you have a look at this, let's say we wanted to do a combination of things. So first of all, let's say we want to do a stretch by a scale factor of 2 in the y direction. Then we want to do a stretch, or rather a translation, 45 degrees, let's do 60 degrees in the x-axis, positive x, it's going to the right, so the red curve has now moved to make the blue curve. And finally, if we wanted to move that curve down, all we have to do is simply say what we want to take away. So if I want to move it down 2 places, I just take away 2. So when you look at this final graph, this one here, that is when you start thinking about how to change the original curve in steps. So the first thing you do is stretch scale factor 2 parallel to the y-axis. Then you do a translation in the x-axis 60 degrees to the right, and then you do a vertical movement of -2. And the order does matter, not always, but it does. If I swap these around, in fact, and what I did here was I actually changed the order of the translations. So I did that one first, and then I did the takeaway 2. It still amounts to the same graph. I just swapped the order of the two. So this is a translation in the x direction, and this was the translation in the y direction. And I finished off with this value afterwards. So we're not going to get too much into that, but some of the questions you'll be asked to do will involve that. So you just have to be a bit careful. So I think I'm going to leave it there. And if people have got some questions, I'll have to answer them live on Desmos. So good luck with that. Stick to the questions and use the prompt sheet that I've put on Shobi. Okay.